Welcome to the last week of BIO127. We're going to be covering the reproductive system as well as a little bit of embryology. So it's going to be chapters 19 and 20, just a little bit of 20, not too much. So we'll focus on male and female reproductive anatomy and physiology. We will talk about conception and development as well as birth, just a little bit, just an overview, because this is an overview. So in our female reproductive system, we will start with a mid-sagittal section. They're saying medial view, but this person has been cut in half. This is a mid-sagittal section. So this is going to be anterior, this is going to be posterior. And we are focusing on the reproductive system. Now, in context, we do have the urinary bladder here with the urethra and the urethral orifice here. The vaginal orifice is here, and the anus is here. So that is 3 distinct holes for 3 distinct systems. Women do not pee out of their vaginas. If there is urine coming out of a vagina, that's a condition known as a fistula. It's a medical problem. Get that checked. So it's 3 separate holes for 3 separate systems in the female reproductive system and the female mid-sagittal pelvis, I should say. So the reproductive system, of course, is going to be the primary sexual organs, which is the uterus and ovaries, or actually rather just the ovaries, the gonads, and then secondary characteristics, which is the rest of it. So there's going to be the uterus, the vagina, the vulva, structures of the vulva. So the vulva is external, the vagina is internal, and those are not interchangeable terms, and I'm going to spend a little bit of time on that. The vagina is an internal structure. It is a muscular sheath leading to the cervix of the uterus, and then laterally on either side of the uterus, there will be the uterine tube, previously known as the fallopian tube. I'm sure some people still use that terminology. We're going to stick with uterine tube, leading to the ovary. Now, the ovary and uterine tube are not directly attached to each other. They're buried in some ligaments, some sheaths. So ovulation is actually going to happen out in the peritoneum, and then we're going to have that egg travel through the uterine tube towards that uterus, and depending on if fertilization and implantation occurs, implantation would occur in the endometrium of the uterus. If not, menstruation occurs, we shed part of that uterine lining, and that leaves through the cervical os, that opening there, and is shed as menses to the external environment. We will go into some other details here. This is the vulva. So when we see the external anatomy of a biologically female person, what we do see is the vulva. We do not directly see the vagina. If you're seeing the vagina, you've probably got some kind of speculum going on. So if somebody gets out of a car without any underpants on, wearing a short skirt, we saw their vulva, we did not see their vagina. That's very distinct terms that everybody, including healthcare professionals, gets mixed up about, which is problematic because there's a big difference between vulvitis and vaginitis, a sore on the vulva versus a sore on the vagina. These are clinically distinct terms, and I want everybody to be aware of that. Now, of course, this is a hairless specimen, which is not at all typical. They've removed all hair to increase visibility, although I think it has a lot more to do with the patriarchy, frankly. I've had textbooks that had some pubic hair in the very least. This one has decided to go without any kind of pubic hair. It's also very, very symmetrical. There's a lot of natural variation in the way that a vulva will appear. Some people will have larger labia minora than their labia majora. Some people will have asymmetrical labia. That is all acceptable. This is just the glans of the clitoris. The textbook does not include information about the full size of the clitoris, which actually I've overlooked. I've updated the pictures in this. Give me a second to get a clitoris for you guys. Okay, we're back, and I found a 3D picture showing you the internal structure of the clitoris. Now, I want you to take a second and guess what year scientists discovered the clitoris. It's always a fun game we get to play. Because, I mean, I have over here, it's like a few steps away for me. I'm giving you some time to think about when the clitoris was discovered. So I have my original Grey's Anatomy reprint, because with like the gold leaf and everything, because I'm a huge anatomy nerd, obviously. And this, of course, does have the original, the full structure of the penis. It's not what's bookmarked, unfortunately. I have the brachial plexus bookmarked. It does have the sort of like full breadth of the erectile tissue that makes up the penis. That was discovered a very, very long time ago in the scientific literature. But the clitoris was only written up in its full structure of all of the erectile tissue in 2009. So that's the year men discovered the clitoris, 2009. They didn't know about it before then, which is obviously a joke. But the whole thing is a joke, because it's actually kind of gross that we did not publicize in academic literature what the clitoris was. So a lot of textbooks still don't have information about the clitoris in its full size and its full breadth. The erectile tissues in the female reproductive system are proportional in size to the erectile tissues in the male reproductive system. So if you took all of the erectile bodies of the penis and put them in the pelvic floor of a male, that would be analogous to what's going on with the clitoris. So labeling that the clitoris is not really accurate. That's the glans of the clitoris, glans of the clitoris, just like the glans of the penis is just one part of the penis. So those are analogous structures as well. So that is slightly covered by a flap of skin known as the prepuce of the clitoris. Labia majora are out here, the urethral orifice here, the vagina here. Again, that urethra is anterior to the vagina. This will be known as the perineum, not to be confused with the peroneum. The peroneal muscles are on the shin, so you really want to enunciate those correctly. The vestibule is just this entire opening area. It's an entryway. Like architecturally, a vestibule is an entryway. So same thing. What have I missed? I think that's been most of it. The uterus itself. My advisor in grad school would do this thing where she would she actually held me up like this and made me look like a uterus to like demonstrate these right here, the suspensory ligaments of the uterus. So the thing about the uterus is that it is suspended in a bunch of ligaments. They're kind of like coating over the back and the front of the uterus, and then there's kind of sandwiched together like wings on either side. I actually have a t-shirt that's like this perfect pink color. It kind of makes me look like a uterus. I usually wear it when I teach reproductive. I don't know why I'm not wearing it right now. It's kind of silly. So you have all these suspensory ligaments. They are suspending the uterine tube, suspensory ligament for the ovary. There's distinct parts of it. They've left out some of the structures. The round ligament is in the middle here. The uterus itself has a fundus. A fundus is a general term for any superior rounded area. So there's a fundus of the stomach, like the top rounded part of the stomach is a fundus. This is the fundus of the uterus. So when you're saying fundus, you always want to say fundus of the uterus, fundus of the stomach. Otherwise, which fundus are you talking about, my friend? The body of the uterus, it does thin out as it gets to the cervix. This is the cervical opening. Different sources will call this the cervical os. Os of the ostium, os of the cervix, opening. Yeah, there's a bunch of different ways to phrase that. There are parts of the uterine tube. It looks like we're condensing it to just the ampulla of the uterine tube and the rest of it. And notice that these are not actually adhered. The ovary is not directly adhered to the uterine tube. It's just sort of nestled in there. And then the uterine tube, the ends of it, another good reason to demonstrate with a person is that the fimbriae are these finger-like extensions on the end of the uterine tube. So when ovulation occurs, those fimbriae can kind of move and kind of usher that egg into that ovum into the uterine tube. That's the goal. Okay, now again, this one's saying oviduct as opposed to uterine tube, and that's fine. Vagina, clitoris, Okay. The uterus does have layers. The endometrium is the deepest layer, and that's variable. Parts of the endometrium are sloughed off during menstrual flow. Not all of it, not the whole thing, just a certain layer that changes throughout pregnancy. Myometrium, that's the thickest layer of the uterus. Most of it is myometrium, and then externally we do have perimetrium. So it feels like a muscle. I did get to feel actually a postpartum uterus, which is sad if you think about it. About less than a year ago is when I saw that one, and I got to palpate it, and it just feels like a strong muscle. Like it feels like a somewhat contracted bicep. If you want to know what a uterus feels like, it's a very muscular organ. Okay. And then cervix we talked about, vagina we talked about those. We will talk about the mammary glands towards the end of female reproductive. So those are a secondary sexual characteristic. They are exocrine glands. So cells are producing milk into a duct, a system of ducts, and that duct collects into larger ducts, and that duct is the external environment, ideally a suckling infant or a bottle for an infant. We'll talk more about ovarian development, the ovarian cycle. So let's talk about the monthly cycle. Actually, yeah. Let's go to ovarian cycle. We'll go back. Go to monthly cycle. We'll go back to specifics for follicular development and a couple of those details that you need for your study guide. This is an important chart. If you go into the health sciences, you're going to see this chart again and again and again and again and again and again. And it's really, really important. It's a lot of clinical relevance here. There's fertility, there's birth control, there's all kinds of things that are related to this chart. So it comes back again and again. The sooner you see it and the sooner you start working on it, the better. And I've seen a couple of different variations. This is what I refer to as the ovarian cycle. I know that it's not labeled here, but this is the ovarian cycle. This is the uterine cycle. So this is what's happening in the uterus throughout a monthly menstrual cycle. And so these things are correlated, and they're correlated based on the actions of different hormones. And this is kind of a weird chart, actually. It's doing some weird stuff. That's okay. Yeah, that's weird. Okay. Sorry, it's different from the chart that I'm used to looking at in a couple of ways. Now, an important place to draw a line is right here. Day 14 is where we mark ovulation. So LH and FSH are two important hormones. These are gonadotropic hormones. So what you're going to do is your hypothalamus, part of your brain, is going to release a chemical. It's going to act as a hormone known as gonadotropic releasing hormone. This is a hormone released by the hypothalamus that will cause the release of your gonadotropins, LH and FSH. And this is true for actually both male and female systems. It's just in the female system, it has a really specific role. LH and FSH are actually going to peak and trigger ovulation. That's why I'm saying this chart's a little bit weird. They actually have to peak a little bit before ovulation in order to trigger it. So especially that LH is going to peak and it's going to trigger ovulation at day 14. So there's ovulation, which again should be on day 14, not after it. That's why this chart's weird. It's still a better chart than the one I replaced with. That's okay. So LH and FSH are the trigger for ovulation. Now, if we're ovulating at day 14, we need a certain state for that uterine lining. That endometrium has to be a certain way. So ovulation is going to be the event that might coincide with fertilization. If this person has had sex within, let's say, 6 days, roughly, and unprotected sex with a biologically male partner, and that sperm entered into either the vulva or vaginal area and traveled through the uterine tubes, and it met a recently ovulated ovum, then fertilization can occur. If fertilization can occur, then some development and eventually implantation can occur. If we want implantation to occur, then this endometrium needs to be thick. We need a thick endometrium lining that uterus. We need for this to be thick and bloody and full, like a comfy place to land, right? So the days before ovulation are days that are associated with the endometrial lining of the uterus becoming thicker. We refer to this as the proliferative phase of the uterine cycle. After ovulation, day 14, we do have these sort of pits and glands in the lining of that endometrium. So we call this the secretory phase. What's being secreted? It's not being secreted by the uterus, it's being secreted by the corpus luteum. We do have a very important peak in progesterone right here. Progestation. So this progesterone is what's keeping the endometrium thick. And of course we do have some glands that are secreting some things as well. So that's why this is the secreting phase, secretory phase. If fertilization and then implantation do not occur, and those are two distinct events, if neither of those events occur, then there's no pregnancy, then menstruation will be initiated. Menstruation, as you can see, coincides with low hormones, low progesterone, low estrogen, low LH, low FSH. Low levels of all hormones are going to be part of our trigger for menses and shedding that uterine lining. And then the process starts all over again as a cycle. So one reason that this is important is the concept of birth control. So a lot of people think incorrectly, that birth control pills mimic early pregnancy. And that's not accurate. What birth control pills mimic is the post-ovulatory phase. So the major thing in birth control pills is progesterone. And some birth control pills will also contain estrogen. That's another thing that makes this graph a little bit weird, is this estrogen peak on other charts is going to look a little bit higher than this. So there is a peak in estrogen before ovulation, but there's another peak in estrogen after ovulation. So when we're taking birth control pills, or somebody's taking birth control pills, they are getting elevated progesterone if it's a mini pill, as well as some form of estrogen if it's the typical pill, in varying quantities for different forms of hormonal birth control. And that does mimic the post-ovulatory phase. That's going to keep LH and FSH low. And we'll see exactly how that happens on another slide. Your body is saying, we've already ovulated, we don't need to ovulate again. So it's a post-ovulatory phase that hormonal birth control is mimicking. Okay, so we went through the entire uterine phase. I've touched on all of the hormones here. The only other thing to add on in the ovarian cycle, so the developing ovum is developing within a structure known as a follicle. So these cells, this little pink thing right here, that's the ovum. That's the thing that actually gets ovulated, right? That's the ovum that can be fertilized. The rest of these cells develop around it. That's the follicle. So the follicle is a collection of supporting cells. They're supporting the ovarian development and supporting ovulation. But the cool thing about this follicle is that it sticks around. It stays after ovulation. It stays in the ovary, and it turns into something known as the corpus luteum. And I kind of already said this, but I'm going to clarify it now. The corpus luteum is actually the thing secreting the progesterone here. So after a while, that corpus luteum, if there's no pregnancy, it actually degrades into something called a corpus albicans, which is not labeled on here, and that's okay. So the corpus luteum decays, it degrades, it becomes a little patch of scar tissue. And again, once it's that scar tissue, it can no longer produce that progesterone. So of course, that's going to be part of our trigger for menstruation. So it's all interrelated. There's a good reason this is all on one chart, right? It's all interrelated. It does get you a lot of clinical information, birth control just being one of them. I did promise you we would go backwards and do a little bit more about follicle development. So again, we've already, during our meiosis lecture, or mitosis and meiosis, really early in the semester, we did talk about oocyte and spermatocyte development. So I don't want to do like a full rehash. I think we've basically done that. It's a repeat. I'm asking you to do like a quick review of it, but it's not going to be one of the major topics for the day. So remember, you've got an oogonium that becomes a primary oocyte, which becomes a secondary oocyte. which becomes, which is ovulated. The secondary oocyte is ovulated. It's still a primary oocyte here. That gets ovulated. Now again, these cells around it, those are the follicle. So at this point, we've just got a single layer of simple cuboidal cells, and that's a primary follicle. And that starts to increase in number. We get more cuboidal cells. Eventually, now some of these follicles do degrade. Not every, I should probably start from the beginning, right? So you are born with just a ton of eggs, right? And only some of them are ever going to actually develop. Once a month, a certain number of primary follicles start to develop. Some degrade, some continue to develop. So there's a generating follicle, but here's one that is increasing, and now we're going to call this a secondary follicle. It has what we call an antrum. It has a little fluid-filled space, but makes it vesicular as well. So a vesicle is a fluid-filled space, a cyst is a fluid-filled space, a lot of words for fluid-filled space. Here is your mature, or also sometimes known as Graafian follicle. It has this very large antrum. How we have many, many layers immediately around the ovum. Those have a specific name. The zona pellucida and corona radiata are the cells immediately around the oocyte. And then you have some more cells. These are the cells that are destined to become the corpus luteum over here. And again, that's going to secrete progesterone. If no pregnancy occurs, then it's going to degrade or degenerate into a corpus luteum. And that's just a piece of it's going to degenerate into something known as a corpus albicans, but they didn't write that. That stays in the ovary. There's just a patch of scar tissue. Every ovulation leads to a new patch of scar tissue on the ovary. So if you ever feel like you're aging and your ovaries are just turning into dust, they are. Not dust, scar tissue. What else did I miss? This is just another version of the same thing. Nobody's labeling the corpus albicans. It's fine for BIO127. We don't need corpus albicans for 127. I'll hold you to it in BIO212. Okay, good. Did all that. Okay, we're caught up. This, you tend to need some time on. This takes some repetition. So I anticipate that you can replay that cycle many times. Did that. That's just another version of the same thing. Now, I did want to rehash the negative feedback loop that is part of our gonadotropin cycle. So the hypothalamus releases GnRH. Now, the hypothalamus is part of the brain. We didn't have an endocrine lecture, so consider this like an endocrine mini lecture. The hypothalamus is part of your brain. It's neural tissue. Your neurons are releasing GnRH, but you know what? They're going into the bloodstream. And once those substances are in the bloodstream, we can go ahead and call them hormones. So that GnRH is going to diffuse via the bloodstream to the anterior pituitary. In endocrinology, we do have to divide anterior and posterior pituitary glands because they have slightly different structure and function. The anterior pituitary has target cells for GnRH. GnRH is a releasing hormone. That R stands for releasing. So this hormone causes the release of another hormone from another gland. That's what a releasing hormone is. So gonadotropin releasing hormone causes the release of gonadotropins from the anterior pituitary. Your gonadotropins are luteinizing hormone and follicle stimulating hormone, LH and FSH. The nice thing about endocrinology, you can always use the acronym. It is always accepted to use the acronym. There is not an endocrinologist alive who will be like, LH, what are you talking about? They'll be like, oh yeah, LH, because hormone names are really long. So it's always okay to use the acronym. Luteinizing hormone. I like saying the whole name of the hormone because they often tell you what they do. The luteinizing hormone is related to the corpus luteum. The follicle stimulating hormone stimulates the follicle. So if you do bother to say the whole name, you get a lot more information out of it. So those are the gonadotropins. And again, these are both the male and the female cycle. They're named for their function in the female cycle. The LH is going to trigger formation of the corpus luteum. FSH is going to support follicular growth and development. When these peak, that is going to trigger ovulation, right? Now, they're also going to correlate with rising levels of estrogen. And this is missing got a link about, that's weird thing. Let me see something. Yeah. Okay, that's why we're doing that. Okay, it does make sense. So positive feedback system, high FSH and rising levels of estrogen increase the level of LH and FSH, but after ovulation and the formation of a corpus luteum and elevated progesterone levels, that's actually going to inhibit the release of GnRH, gonadotropin releasing hormone, which explains why that birth control pill is going to decrease LH and FSH and prevent ovulation. So that's what this is. There's a dividing line here. Positive feedback in the, let's see, call it the follicular phase, and the luteal phase is when we'll have negative feedback. Okay, and that's all in here, in case you missed any of that or you need a review. Secondary sexual characteristics of the breast tissue. This is the histological organization of the mammary glands. So you have these simple cuboidal cells lining, and they are exocrine cells. So they do secrete their products via vesicles into the space of the alveolus. And then you would zoom out a little bit more, you would see them bunched together like this. So they're all secreting into ducts that merge into larger ducts. Those are called lactiferous ducts, and that does lead to the milk being going into the external environment. Now, why is this important? Breast cancer, the cells for breast cancer are either ductal cells, cells of the ducts, or lobular cells, cells of the lobule. Those are really, really common phrases in breast cancer physiology. So they're good words to know, to understand this organization, so that you can understand the difference between a ductal cell versus a lobular cell, and how those might have some slightly different form and function connections and lead to slightly different forms of breast cancer. There's also suspensory ligaments in here. Those actually get weaker if you wear, like, especially an underwire bra. The research was done with underwire. Nobody did like sports bra research for these. The more you support the breast externally, supposedly, the weaker those suspensory ligaments get. So women who do not wear, people with breasts who do not wear underwire bras actually have measurably higher nipples than people, like, higher on the body than people who do wear bras. And that's controlling for size. So even very large breasted women who do not wear bras will have a nipple that is positioned in a higher position than somebody who does with the same breast size. So we should all burn our bras, is the takeaway from that. Or not. Do what you want. I don't think anybody's wearing a bra during COVID when this is being recorded. So, you know, have fun. Okay, we did that, and that's a good stopping point. Female reproductive, we'll do a separate video for male reproductive, and then we've got some special topics.